Very good morning students, Jai Gurudev. Right now we are studying elasticity chapter. And this is the second lecture of this chapter. In previous lecture we have done what is stress, right? What is stress? As we applied the external force on the body, any body, and it react, right? And the equation of stress, that is, stress is equal to force divided by area, external force divided by area, and the unit of this, that is Newton per meter square. That is the unit of stress. Then after we have done types of stress, that are longitudinal stress and another one, that is volume stress. When we apply the force in length, at that time the stress created, that stress is called longitudinal stress. When we apply the stress equally in every side, at that time the stress created, that is volume stress, right? Then next we learn strain. Then after we have done the strain, as per the different shape, this strain also divided in three parts, that is longitudinal strain, next that is volume strain, and third that is shear strain. In longitudinal strain, we are told that the change in length due to stress, the change in length and original length, the ratio of change in length and unit length is called the longitudinal strain. When we apply force equal in every side, at that time the change in volume, the ratio of change in volume and total volume is called, original volume is called volume strain, and this quantity is a unitless quantity because this is the ratio of same quantity, right? Change in length divided by original length, change in volume divided by original volume. And right now we are at shear strain. Now the question is, what is a shear strain? It is little much different than longitudinal strain and volume strain. Shear strain. Suppose we have one stand. Right now, suppose I have a duster. I stick this duster at this base. Anyhow, this could not move from this base, right? Still I give force. What happened? કે નીચેનો બેઝ છે એ સ્ટેન્ડ જેટલો રહેશે and this will change. Maybe the pressure is more, at that time it happens that upward direction shape will become change, but downward direction at this place. I give example with figure. Suppose this is the ABCD. Okay, I change the name ABCD. You can give any name, okay? Now I give the force from this side. This base is fixed base. This base could not move, but when we give force, this may be happen. AB is fixed, CD, here D dash and C dash. This will happen or not? This happened in many times in earthquake. Earthquakeમાં ઘણી વખત આવું થાય છે. ભૂકંપ આવે ત્યારે તમારી બિલ્ડિંગ છે ને બેઝ છે પકડાયેલો હોય, પાયા મજબૂત હોય, બેઝ છે નીચે હોય, ફ્લેટ છે ઉપરથી મૂવ, નીચેથી મૂવ, આવી રીતે થતો હોય. ફોર્સ લાગે એક સાઈડથી. This will happen, right? And this is the best. This is the example of shear strain. When the base is fixed, but upward directions displaced somewhere at a right angle. કોઈ એક angle થી displace થયેલો. Suppose that angle that is theta. Okay. Suppose this AB is having a length L, capital L. So CD also having a capital L length. Okay. Now when this displacement that is small l. Suppose our displacement is small l જેટલું થયું. If this one is small l, so we can say this one also small l. Okay, and this is called shear strain. Now if we want to find the strain, here if we want to find the strain, what to do? The equation here, that is tan theta. To find the shear strain, here we need to find tan theta. Suppose this is a cube. Every length that are L, જો સ્ક્વેર થશે તો શું થશે? બધી લેન્થ L હશે. આ લેન્થ L છે, આ લેન્થ કેવી થશે? That is that we need to find. આ છે એ આપણે find કરવાની છે. Suppose here is a theta. If we want to find tan theta, we need to find tangent of this. આપણે shear strain શોધવું છે, મતલબ કે આ બંને વચ્ચેનો ચેન્જ છે, that is this one, right? એટલે કે આ લાઈન શોધવાની થઈ. ઓકે, હવે આ લાઈન શોધવી છે તો શું કરવું પડે? here we need to take a tangent. Tangent મતલબ કે tan theta. Tan theta નું ઇક્વેશન શું છે? I am sure you all remember that સામેની બાજુ છેદમાં પાસેની બાજુ. Opposite divided by adjacent. આને કહેવાશે સામેની બાજુને opposite, પાસેની બાજુને કહેવાશે adjacent, and this one is called hyperbola, colon. Okay, now here tan theta, that is આ સાઈડ શોધવી છે તો કઈ રીતે મળે? આ બંનેનો રેશિયો મળી જશે. ઓકે, ઓપોઝિટ ડિવાઇડેડ બાય એડજસન્ટ. હિયર ઓપોઝિટ ધેટ ઇઝ સામેની બાજુ થીટાની કઈ છે? dd dash. So dd dash divided by adjacent. Here we are using triangle ADD dash. Okay, now dd dash divided by AD. Okay, this is the value of shear strain. Here the value of dd dash, that is L, divided by AD, the value of AD, that is capital L. Here you can see that the equation is same as longitudinal strain, that is change in length divided by original length. But we could not say directly like longitudinal strain. That's why here we divided this two parts, longitudinal strain and shear strain. Before in stress we are using just a single word, longitudinal or shear stress, because stress is same but here strain is little much different. Reason is here tan theta. When the theta is small, we can say also theta is equal to L divided by L. તમે આવું કરેલું જશે, જ્યારે થીટા બહુ નાનો હોય ત્યારે tan theta equal to theta છે એ ધારી લેવાનું. Okay, so this is the value of shear strain. When again I repeat the shear strain, here the base is similar. Suppose we have a cube, the base is fixed. At that time when we give a force, base is fixed. Is it possible? Suppose here ABCD cube having a length L. When we give a force F to this cube, AB is due to fixed AB, so that AB could not move, but CD is displaced. CD convert in C dash D dash. Okay, at that time the shear strain here, it makes a right angle theta. Okay, so if we want to find the tan theta, if the change in dd dash is equal to small l, so that tan theta is equal to opposite upon adjacent, that is dd dash divided by AD. Here dd dash, that is small l, and AD, that is capital L. So tan theta is equal to theta. When theta is so much small, at that time tan theta is equal to small l divided by L. This is also unitless quantity because both are length. Are you getting my point? Here theta is such a small, reason is here we are using rigid body. Rigid body मतलब કે solid body, કોઈ પણ solid body છે ને ગમે તેટલું force એટલો બધો angle પણ મોટો બને નહીં, બહુ just small angle. So that we are taking here tan theta approximate theta. Is it clear everyone? This is a type of strain, shear strain. Okay. Now based on the strain types, we learn another question, that is Hooke's law. Now we learn total 3 type of strain, that are longitudinal strain, volume strain and shear strain. And every strain are unitless quantity. Must remember આ બંનેમાં અલગ અલગ કરો છો તમે, આડાવડું બી કરો છો. સ્ટ્રેસ છે ઓલવેઝ રિમેમ્બર ક્યારે યુનિટ યાદ રાખવા કરતાં એનું ઇક્વેશન અથવા ડેફિનેશન યાદ રાખવાની. મસ્ટ રિમેમ્બર ઇક્વેશન યાદ રાખો. સપોઝ સ્ટ્રેસ ઇઝ ઇક્વલ ટુ ફોર્સ ડિવાઇડેડ બાય એરિયા. આના પરથી ડેફિનેશન બી બની શકે. The ratio of, otherwise you can say ratio of external force and the unit area is called stress. When you give external force to the unit area, and this quantity is called stress. Next, આના પરથી force નો unit newton છે divided by area નો unit meter square. આ રીતે યાદ રાખો તો બેટર રહેશે. યુનિટ ગોખવા કરતાં એના ઇક્વેશન પરથી યુનિટ બનાવી અને લખવા, આ બંનેમાં આડાવડા યુનિટ ઘણી વખત સ્ટુડન્ટ્સે કરેલા છે. Okay. Now the next question, that is Hooke's law, or another name of this question, that is modulus of rigidity. Now in here Hooke's law or modulus of rigidity, a binary question પૂછાય છે, and this is IMP question. Basically this question is divided in 3 parts and every parts are important. So many time individual ask, sometime 5 marks every types are asking. Okay, so must remember Hooke's law or modulus of rigidity. A question છે Hooke's law. It is discovered by Robert Hooke. That's why this law is known as Hooke's law. This law is founded by Robert Hooke. Okay, Robert Hooke discovered that if a deformation is small, the stress of the body if the deformation is too small, the stress of the body is proportional to the strain of the body. After founding the stress and strain, Robert Hooke found the relation between stress and strain. We all know that stress is equal to force upon area, and the strain, that is change in length divided by original. Okay. Now after this, Robert Hooke discovered that the relation between stress and strain, and the relation between stress and strain, that is if a deformation is small, the stress of the body is proportional to the strain of the body. Now the question is, what this is asking? Okay, that is deformation मतलब के આપણે જે changes આવે છે, deform થાય છે, એનો original shape છે એ છોડવો. If the shape is cube and when it converts in another shape, if the shape is circular it converts in another size shape. Okay, તો એ ડિફોર્મેશન જે ચેન્જીસ આવે છે શેપમાં સાઇઝમાં એ જો નાના હોય બહુ સ્મોલ હોય કે બહુ થોડું એવું હોય એટ ધેટ ટાઈમ ધ સ્ટ્રેસ ઓફ ધ બોડીનો સ્ટ્રેસ છે એ બોડીના સ્ટ્રેન જેટલો હોય છે. સ્ટ્રેસ એન્ડ સ્ટ્રેન બોથ આર પ્રપોઝનલ, રાઈટ? So that we can write this law like that. Stress is proportional to strain. Must remember the condition. If the deformation is small, at that time stress is proportional to strain. Right? Now if we want to remove the proportional, we can do like that. Stress divided by strain is equal to constant E. We remove the proportional and we are using constant E. Here we are studying elasticity, so that we are using constant E. Okay, stress divided by strain is equal to constant E. The name of the E, that is elasticity of the body. Elastic constant of the elastic body. Elastic constant of the elastic body. Modulus of rigidity, I think. Next, that is modulus of rigidity. Yes, modulus of elasticity of the body. These are the name of this constant. Stress upon strain is equal to constant E, and the name of the constant that are elastic constant of elastic body, or I can say modulus of elasticity of the body. Okay, here this relation, this Hooke's law does not depend on stress and strain. Stress and strain ઉપર depend નથી કરતો, actually constant પર depend કરે છે. Every material have a different constant. Okay, constant value છે દરેક material માટે different. So basically this Hooke's law does not depend on stress and strain. Basically it depends on nature of the material, and modulus of the material, or I can say the next depends manner in which the body is deformed. નોર્મલી આજે છે સ્ટ્રેસ અને સ્ટ્રેન પર ડિપેન્ડ નથી કરતું હુક્સ લો, એના ઉપર ડિપેન્ડ કરે નેચર ઓફ ધ મટીરિયલ, મતલબ કે મટીરિયલનો નેચર કેવો છે, સોલિડ છે, લિક્વિડ છે. નેક્સ્ટ નેચર ધેટ ઇઝ કે એનું સપોઝ કહીએ તો એ કન્ડક્ટિંગ મટીરિયલ છે કે નહીં. નેક્સ્ટ ધેટ ઇઝ નેચર, ઇલાસ્ટિક નેચર છે કે નહીં, એના પર મેઇનલી ડિપેન્ડ કરે છે. એન્ડ ધ નેક્સ્ટ ધેટ ઇઝ મેનર ઇન વિચ ઇટ ડિફોર્મ, કે કઈ મેથડથી ડિફોર્મ થયો છે, લાઈક લોન્જિટ્યુડિનલી ડિફોર્મ થયો છે, really વોલ્યુમેટિકલી ડિફોર્મ થયો છે, શિયર ડિફોર્મ થયો છે, કયા મેથડથી ડિફોર્મ થાય છે, અને એ મટીરિયલ જે તે છે કે જે ડિફોર્મ થયું છે એનો નેચર કેવો છે, આ બંને વસ્તુ ઉપર ડિપેન્ડ કરે હુક્સ લો. ઓકે, now Robert Hooke discovered that if this deformation is small, at that time the stress of the body is proportional to the strain of the body. So that we can say stress proportional to strain. Now the equation becomes stress upon stress is equal to constant E. Okay, now this equation, in this equation the constant E is called elastic constant of the elastic body, and otherwise modulus of the elasticity of the body. Here the equation normally material does not depends on stress and strain, but it depends on nature of the material and manner in which the body is deformed. Okay, now due to this deform પર ડિપેન્ડ કરે અને નેચર મટીરિયલના ઉપર ડિપેન્ડ કરે. So basically કઈ રીતે ડિફોર્મ થાય છે? As I told you કે longitudinally ડિફોર્મ થાય છે, વોલ્યુમેટ્રિકલી ડિફોર્મ થાય છે કે shearly ડિફોર્મ થાય છે. So that here are also three types. Corresponding to the types of strain. કે જો કઈ રીતે ડિફોર્મ થાય છે એના પર ડિપેન્ડ કરતું હોય તો ડિફોર્મ થવાના 3 ટાઈપ્સ છે, રાઈટ? તો હુક્સ લો બી 3 મેથડથી થશે. Corresponding to the types of strain, first that is longitudinal strain. Corresponding to longitudinal strain corresponding to Young modulus. Young modulus corresponding to જો યંગ મોડ્યુલસ જો કોરસ્પોન્ડિંગ લોન્જિટ્યુડિનલ મેથડથી જો સ્ટ્રેન થતું હોય તો એના કયું થશે? યંગ મોડ્યુલસ કહેવાશે. એનું જે મોડ્યુલસ ઓફ રિજિડિટી કીધું એ ઇક્વેશન છે એને શું કહેવાશે આપણે? યંગ મોડ્યુલસ કહેવાશે. નેક્સ્ટ ધેટ ઇઝ બલ્ક મોડ્યુલસ. corresponding to volume strain. And third that is shear modulus. Corresponding to shear strain. मतलब કે જેવું સ્ટ્રેન થાય જે ટાઈપનું સ્ટ્રેન થાય એના ઉપરથી આ મોડ્યુલસ ઓફ રિજિડિટીનું નામ છે એ નક્કી થાય. ઇફ ધ લોન્જિટ્યુડિનલ ટાઈપનું સ્ટ્રેન થાય તો એ છે એ શું કહેવાશે? ધેટ ઇઝ યંગ મોડ્યુલસ. જો વોલ્યુમ સ્ટ્રેન થશે ધેટ ઇઝ બલ્ક મોડ્યુલસ અને શિયર સ્ટ્રેન છે તો શિયર મોડ્યુલસ. ઇક્વેશન હુક્સ લોનું એ જ છે પણ જો આ લોન્જિટ્યુડિનલ સ્ટ્રેન માટે થાય તો એનું નામ યંગ મોડ્યુલસ થઈ જશે. Volume strain at that time the name that is bulk modulus. If the name that is shear strain at that time naam છે shear modulus થઈ જશે. Little much differences otherwise everyone are same. Let's see individually. Okay, starting from the young modulus. Let's start the young modulus. Okay, young modulus corresponding to the longitudinal strain. Okay, as per the definition of Hooke's law. Hooke's law is what? Stress and strain no ratio. But here we are using longitudinal strain. Okay, so the Hooke's law ratio of longitudinal stress and corresponding to longitudinal strain is called Young modulus. Remember that આ ત્રણે જે નામ આપ્યા છે એ કોના આપ્યા છે? તમે જે કોન્સ્ટન્ટ ઈ લખો તો એના. ઓકે, તો અહીંયા જે આપણે લેન્થ યુઝ કરીએ તો શું આવશે? યંગ મોડ્યુલસ કહેવાશે. So the equation that is longitudinal stress divided by longitudinal strain is equal to Young modulus. Here the Young modulus, which is denoted by capital Y. Capital Y છે ને Young modulus કીધું. Okay? Modulus. Okay? Now we see individually longitudinal stress and a longitudinal stress. Suppose we have a L length wire. Suppose wire of the length, original length, that is capital L, and we give a force F to this length. Okay, આપણે આ જે ફોર્સ છે એને ફોર્સ આપીએ એ કેટલો આપ્યો આપણે F જેટલો આપ્યો. સપોઝ એ વાયરનો એરિયા કેપિટલ A છે. Now after giving force F, the change in length that is a small, okay. Here total length that is L plus L. Total length છે L plus small l થશે તો change in length that is small l થઈ. Okay. Now the longitudinal stress. So here suppose આપણી પાસે capital L length નો wire છે. એની length કેટલી? Capital L જેટલી. And the area of this wire that is capital A. After giving force F જેટલું આપ્યું, length છે L plus L જેટલી થઈ ગઈ. Suppose first we have a capital length L, area that is A. After giving force F, length becomes capital L plus L, so that we can say change in length that is small l. Okay. Now the longitudinal stress, equation of longitudinal stress, that is force divided by area. This is force that is F and area that is capital A. Okay. This is the equation of longitudinal stress. Now the equation of longitudinal strain. Equation of longitudinal strain, that is change in length divided by original length. Here change in length that is small l and divided by original length that is capital L. ખાસ યાદ રાખવાનું, સ્ટ્રેન લઈએ ત્યારે ચેન્જ થયા પછીની લેન્થ નથી લેવાની. ચેન્જ જેટલો ચેન્જ છે ખાલી એ જ લેવાનો છે. ચેન્જ થયા પછીની લેન્થ ધેટ ઇઝ L પ્લસ L છે, પણ આપણે ખાલી ચેન્જ લેવાનું છે. તો ચેન્જ ધેટ ઇઝ સ્મોલ. ઓલવેઝ રિમેમ્બર, ચેન્જિંગ લેન્થ નથી, ચેન્જ ઇન લેન્થ છે. ઓકે. સો ધ ઇક્વેશન બીકમ્સ સ્મોલ L અપોન L. તો હવે આનું આપણે સિમ્પ્લિફિકેશન કરીએ, ધેટ ઇઝ F L અપોન સ્મોલ L ઇન્ટુ A. આ રીતે થશે. આ છેદનો છેદ છે એ ઉપર જશે અને અંશનો છેદ છે એ નીચે આવશે. સો ધ ઇક્વેશન બીકમ્સ F L અપોન સ્મોલ L ઇન્ટુ A. તો હવે આનો હુક્સ યંગ મોડ્યુલસનો યુનિટ શું થશે? ધેટ ઇઝ અહીંયા L L બનેલો લેન્થનો યુનિટ ઉડી જશે, રાઈટ. તો ફોર્સ અપોન એરિયાનો જ યુનિટ થશે. સો ધ યુનિટ બીકમ્સ ન્યૂટન પર મીટર square. This is the unit of Young modulus. Okay. So this is the Young modulus equation. Again we repeat, Young modulus corresponding to the longitudinal strain. As per the definition of Hooke's law, the ratio of longitudinal strength and corresponding to the longitudinal strain is called Hooke's Young modulus. Longitudinal stress divided by longitudinal strain is equal to Young modulus, which is denoted by capital Y. Now the unit of stress, suppose we have a L length wire and area, cross sectional area, that is capital A. Now we are giving force F to this length wire and the change in length, total length, that is L plus L, so that the change in length, that is small l. Now stress, equation of longitudinal stress, that is force divided by area, that is F upon A. Now the equation of strain, so that equation, that is change in length divided by original length, so that small l divided by L. Now put all these value in equation. So the equation becomes FL divided by small LA, and the unit of Young modulus, that is Newton per meter square, and that is Young modulus. We have done Young modulus. Today we have done, first we have done shear strain, then after as per the strain, types of strain, after learning stress and strain, we find a relation between stress and strain. Hooke discovered that the relation between stress and strain, that is called Hooke's law, or I can say modulus of rigidity, right? And this equation said stress upon strain is equal to constant E. હવે આના પરથી strain depends on nature of the material, and the next one, that is manner in which it deform. Deform થવાના manner પર depend કરે, તો એ ત્રણ ટાઈપ્સનો deform થઈ શકે, which are depends on strain. તો strain પરથી એના ટાઈપ્સ પહેલા longitudinal હોય તો young modulus, volume strain હોય તો bulk modulus, અને shear strain હોય તો shear modulus. In these three types we have done young modulus. Okay, અહીંયા સુધી complete કર્યું. In next lecture we will start with bulk modulus, and then after shear modulus, and then after next new question, that is Poisson ratio, that we will learn in next lecture. Thank you. Bye bye.